Okay. So this is the last official piece of content that we're going to cover before we roll into like the final post assessment. There is an entire class on this. I say this on everything leading up to creating like basically a pipeline for ML operations and deployment. I'm going to try and expound on this as much as possible, just to make sure that you have as much opportunity to understand this, because for most of us, this is pretty like far down. Like for me, it's primary, but for the rest of you, it's probably like, hey, just deploy it. You might have somebody else who does this for you. SageMaker makes this really easy. So what we're talking about particularly is about you finally got a model that you cannot optimize any further. It already meets the business goals and needs, and you just want to deploy it. Now, notice that we're not going to talk about necessarily conceptual. Well, I think we might talk about conceptual drift. We're not going to talk about the automated process you would want to create to retrain data if that's applicable to your model, right? Because remember, all models are static. They're not living things. So without new data, they're going to break down over time, depending on, again, the specific business problem you're solving. In general, man-made systems do not auto-maintain, so we have to auto-maintain them in order to make sure they stay up to date and relevant, which is too bad because, you know, if you're not maintaining it, it's typically decaying in a man-made system, typically. So we're going to talk about model deployment, right? Inference types, monitoring models. And again, you know, this is really like what tools would you use to get the metrics? Because you know the metrics are being emitted because you saw that in the labs. And then possibilities around how you deploy models. This is going to be on the exam, the deployment approaches. So we are going to talk about that. Okay. All right. So the model's ready. It's trained, it's tuned, it's tested, ready to go. Right. So then how do you deploy it at that point in time? Now, back in my day, it sounds like walking uphill in the snow both ways to school, is that back in my day in 2013, 2014, 2015, 2016, you'd have to kick this out onto a bunch of virtual machines, put a load balancer in front of it. And then if you're, for example, recommender had 17 facets to it, you have to scale 17 facets times whatever number you needed. Try to calculate the number of recommendations per second it could actually churn out, and then multiply your hardware infrastructure, or, you know, if you're using AWS, your virtual machines, by the number of transactions per second you would get per virtual machine. And then you'd have to scale that out, manually turn the dial, maybe do some auto scaling. But basically what would happen is you'd have a single point of entry. So the API calls would come into a load balancer, and then you'd have n number of virtual machines behind it, hopefully ready to handle these inferences, right? So the problem is that model deployment hasn't shifted a whole lot further from that. It's that, how do we weave, for example, our recommender, our predictor, our inferencer of whatever type, how do we weave that in to a production environment? Now, this could be, by the way, inside, like it could be on AWS, it could be outside of AWS, it could be in the production account, it could be in the non-production account. It doesn't really matter. But somewhere you're going to have some kind of app that's capturing like new data that's going to be stored probably with the existing production data, but that hopefully there's a clear marker or divide between what you trained on and what you, right, are now accumulating. And then you've got the model itself, which is trained, right? We've got a trained model, and we've got some production data that's continuing to grow. Now, let's just to throw this out there. What does Amazon think is the best place to store unpredictable growth, like storage? Like where would you store that at? What's the cheapest way to store data that has unpredictable growth? Yeah, S3. Now within that could be Glacier or whatever, but we're not making those distinctions. So meanwhile, though, the app that's taking in all these, like let's say it's ClickStream Analytics, for example, because it's monitoring what users are doing on your website, it's writing data like to Kafka or Kinesis, and that data is being written out to S3. So you got new data coming in, you got your existing model. Now, with inferencing, what would happen is that your model is then going to get out to like a hosted machine, like a virtual machine of some type, and it could go via container. So let's not get all hung up on that, right? And then what happens is that periodically, by the way, your data should get retrained, and that's almost like a separate thing. But honestly, once your model is trained, what will happen is that the app's actually going to make a request and say, hey, I need to know what this user is likely to buy given this set of parameters, right? And then it's going to return back a prediction. So that's what the inferencing does, is it takes the model, gets new data from the app in question, data it's never seen before. It could be image data, it could be video data, right? It could be tabular, it doesn't really matter. But it's like, I need a prediction. And that's what the inferencing section does, is it gets new little tidbits of data. Now, I also want to be clear about this, is that that new data also should be stored in mass somewhere, including the outcome, because then, right, you can then use that to either train further iterations of the model. But what we're really talking about here is just online, real-time, non-labeled data hitting our trained model, who in turn is providing predictions down. That's what's happening. So our model is out in production. It's seeing new data points or new data sets, and it is making predictions about those new data points or those new data sets. Now, as you update that model on the back end periodically on the left-hand side, because you're continuing to train it, it's gonna, the inference is gonna import the new model. Now, how is that gonna happen? We're gonna talk about deployment approaches, because it's not just gonna do it on the fly, right? You have to checkpoint it and say, I want to deploy a new version of my model, right? So make sure we're clear on that. And then what happens is that your inferencing piece is going to have to scale, because what if out of a single virtual machine, you can get 100 recommenders per second in under 100 milliseconds? Let me repeat what I just said. What if with a single virtual machine, you can get 100 recommendations per second that will turn back those 100 recommendations at under 100 milliseconds? By the way, 100 milliseconds might be too fast. Maybe 300 milliseconds of returning a recommendation is totally fine. But remember that your recommendation is actually part of a larger app, and there's other things going on in that application. So you want to try and get it to return recommendations as quickly as possible and as efficiently as possible, because if that virtual machine can only return 3 recommendations, let's say predictions, sorry, I keep saying recommendations, 3 predictions per second, right? That's not very efficient for an entire like 4 processor, 16 gig virtual machine. But it might be worth it from a business perspective. I don't know. Depends on what you're predicting. Okay. So you've got an inferencing layer, and that inferencing layer could scale to 1,000 virtual machines as it returns predictions back to your app. Scaling, by the way, you can set auto scaling when you define a deployment. You can actually set auto scaling, which means you can say, look, I want you to run a minimum of 2 virtual machines with my model on top of it, all the way up to 1,000 if you want to, or higher, right? And what it will do, by the way, is that you'll specify a metric that you want it to track, either like CPU utilization or latency or some other metric, and it will scale the number of virtual machines underneath that inferencing endpoint to whatever you need it to be to stay at that metric. It's called target tracking. That's not going to be on the exam. You just need to know that you can do it, right? By the way, what's it called when a model in production tends to slowly degrade in accuracy and all that other stuff over time and requires retraining? What is that called? Yeah, concept drift. Okay, so we're about to go we're going to move into deployment. Then we're going to talk about inferencing. We're going to talk about monitoring. We're going to talk about serving. So just bear with me. Oh wait, it does say concept drift there. Maybe I should actually look at the slides. Notice, by the way, monitoring is going to be done by which service? We already talked about this. Which service does metrics and monitoring? Good. Which service is a security service that tracks all API calls made against your AWS account, regardless of where they come from? So every time you're in a notebook and you run fit or deploy or anything like that, you're making an API call from the notebook against your account. That's going to show up in CloudTrail. That's why it was part of the answers for, sorry, that's why it was part of the answers for the practice exams. Is because all your API calls are going to show up in CloudTrail. Sorry, I just had a headache there for a second. Okay, so now you can do this the rough way. Remember, I was joking about walking uphill in the snow both ways to school, which I've never lived in a snowy place, so I just made all that up. Just know is that you can still roll your own virtual machines if you want to do all this manually. You can actually just deploy it on virtual machines. You could deploy it on containers. A lot of people, about half of the people I deal with, actually roll it onto Kubernetes, but they use the managed Kubernetes service. So just know you can actually set this whole thing up if you want, where you do all the pieces. Now, I think we've made it pretty clear about how Amazon feels about that. That's a big no. That's a big negatory for them. What they'd rather you do is they want you to use SageMaker. You can deploy, as you have seen, you can deploy production-ready endpoints with your model, like that. Now, I say like that could be 10 or 15 minutes. But still, that, by the way, that 10 or 15 minutes could be 100 machines booting simultaneously. Whether it's 1 or 10 virtual machines, you're not going to see an increase in load time, right? It just depends. Just, to be upfront about it, that 5 to 10 minutes, 5 to 15 minutes is not going to change if you have 1,000 machines booting on the back end. So what this is going to do is it's going to provide a single endpoint for basically an API call, right? Where you hit the endpoint, you submit, or what? Sorry. Yeah, I'm going to leave that alone. You basically hit the endpoint, you submit certain variables or a data set or a file reference or something else as you push to the SageMaker endpoint, and it's going to return either immediately predictions based on the single data point you submitted, or it's going to process the whole batch of data points that you submitted, and it's going to return you values for the whole batch. So you're either going to do it one data point at a time, or you're going to do it in batches. Those are really the two ways that gets approached. So all the auto scaling and everything else that I was talking about just happens for you. It literally is just parameters inside your setup of the deployment. That's it. Yeah. So obviously you're going to create the model, right? Right. And then whether this is going to be on demand or real time versus, or online, that's another name for it, versus a batch inference job, right? Just, just have to let it know and specify it. Then you're going to create an endpoint configuration, right? Which is going to then be associated with one or more models. You could host different model types behind an endpoint. You just have to, in the call to the endpoint, you just have to specify which variant that you want. We're going to talk more about that when we get to deployment. You will have to have configurations, by the way, for each of those variants. By the way, if you have 3, let's say you've 3 is a bad idea. Let's do 2. If you have 2 variants and they're of the same model, but you're testing one because you think it's the next generation of the previous one, you can make it so that 95% of your traffic goes to the old existing production model that's been handling traffic, and 5% of your traffic can go to the other one because you're doing A/B testing or canary testing or whatever form of testing you want to call it, right? And by the way, if that 5% doesn't work out, it throws a bunch of errors and the predictions are horrible and your metrics are off, you just roll it back to the 95%, make 100% traffic, the old version, right? So blue, green, canary, linear, right? So this is all about deployment. Now note that when you set up an endpoint, which again, you've seen this already in your code, is that you're naming the variant, you're naming the model, you're specifying the number of instances, and you don't really have to worry about like distributed consensus computing when you run your models, because all you're doing is deploying the model, which in turn is just making predictions. I mean, it doesn't really need access to a data set, right? It's really just a mathematical formula. Okay. Amazon's going to create all this required infrastructure for you. Notice that you can set min count, you can turn on auto scaling, you can set max. So you can set the minimum and maximum servers that you want here. You could specify multiple variants. You could put weights on the variants, right? Okay. So you would create the endpoint, then you would deploy the endpoint. Again, still using the endpoint. This is the configuration where you define the actual configuration of the endpoint. And this is where you actually deploy the endpoint. Now we've seen this already. We've seen the estimator. We've seen the hyperparameters being set. We've seen the training, the training job being called and executed. And then we've seen the deployment at the very bottom. Remember that I said that you could actually do 100% cutovers from one variant to the next variant. You will have to deploy new configuration files when you do that, by the way, because you're changing the config every time. And then with Canary, you can do the same thing. You don't have to create new endpoints. You just have to deploy a new configuration file that says, hey, I want 100% of traffic on blue, 0 on green. Now I'm going to deploy it and I want 100% to go to green and 0 to go to blue. That is a blue-green deployment strategy where it's literally a 100% throw over the wall cutover. If it fails, you go back to blue. Canary is where you stick your toe in the water, to borrow a phrase. Canary, and that comes from the unfortunate use of canaries in coal mines because birds have more fragile lungs. And so when gas would start to accumulate, birds would start to get agitated because they would start to feel some pressure in their lungs, which means that human beings were not far behind from feeling it because we couldn't smell the gas, right? Which is why gas smells now, because we added that in. So anyway, horrible little piece of history there. But what that means is that canary means we're just sticking a small amount of our traffic onto the variant, the new model. We're keeping the bulk of our traffic on the old model. And as we test it out, we're going to flip it. So we might go to 100% at that point in time. Does that not make sense to anybody? When you do this, by the way, when you do blue-green, just know that you create a new endpoint configuration, basically defining that there's 2 other variants, right? Specifying the weights, you implement that, right? You create and test green. So like you could actually test your calls in production without having green take any production traffic. In other words, you could deploy green into production and then you could run test data across that endpoint by explicitly calling the green variant while your app is still using the blue variant for all of its customer traffic. So you get to test at every step and not necessarily impact customer data. Once you feel like everything's solid, then you just switch to green. And then eventually you roll out a new config and you delete blue because green is so solid that you're comfortable with the former green now becoming the primary system, the primary variant for the model. The A/B testing, by the way, allows you to put different weights, right, on different variants of your model. So once again, for example, you could put a small portion of traffic, so a small portion of customers on the new endpoint like in this particular case, route a small number of users from your web app to the new endpoint, right? And then flip it over. So a couple of users go to green, and the next thing you knew, right? And if you run into a problem, you just roll back to the previous version. If everything looks great, there's no failures, everything looks cool, you could also just roll it over that way as well. Now, what people commonly ask me here is that, well, Michael, can I stick like a load balancer or like an application gateway in front of the endpoints? Yes, you can. You can't stick a load balancer, but you can stick an application gateway. So the difference between blue green is it's 100% code over. It's either 0 or 100. With Canary, you're putting a small percentage of traffic onto the new variant of production traffic and just seeing how it goes. And then you can either scale it from there, or you can just route all the traffic in. Okay. Okay. Here's another sample config file. Like this is a configuration for an endpoint where you've got two production variants defined, right? Notice the weights are the same. Those numbers can be arbitrary, by the way. You could make 110 and 11. It doesn't matter as long as they're integers, right? Any questions there? This is a little weird. Canary usually involves a small amount of traffic, like 5% or 10%. This is just an even split. So it's more like A/B testing. Canary would be like 95-5 or 90-10. Because Canary it's like, think of like we're using canaries compared to human beings. The canaries are a small percentage of traffic. The human beings are a lot more like larger as a result. This is more like a even like 50-50 A/B split. It's a little weird. I Google does this, I know for a fact, but like I don't know that most other customers I meet would do this kind of testing. Let's let half of our users use a new feature. That could happen. But I don't see people doing this. I'm sorry, I said Google does this. Google does this with application features. I don't see anybody doing this at all with the recommenders. Just to say this. Does Canary and A/B always affect production traffic? All deployments affect production traffic, Nicholas, whether it's blue, green, or Canary or A/B. There might be another question there that I'm not hearing. Because what you might be asking is that, if you're doing Canary and A/B, does it always straddle between two different versions of the model? Yes. So does blue green, but the difference is you're cutting over to one version or cutting back to another version, so you're not splitting traffic. Canary and A/B always split traffic. But sound like you were gonna have a question, Nicholas.
Yeah, I was just, I guess, I was stuck on that, the dotted line that you were showing before for the blue green.
For the blue green.
No, not that one. The next, I think it's the next slide. Or yeah, this one.
Yeah, so you deployed a blue and you deployed a green, but the solid line indicates that all of your production traffic, right, is still going to blue, which is where it's been going the entire time.
Okay. So
Yeah.
when does the dotted line, when does it come into play? When you enable it, I guess?
Yeah, so this actually is probably a mistake, honestly, because like this should actually be a dotted line. So there should be some breaks here, right? This should be a
Okay.
dotted line. Because what's happening is that this guy is actually not getting any traffic at that point.
Mhm.
right? All the traffic's going over here.
And can you use with blue green? Can you use the AB or the canary approach? Like you can deploy, and I guess it's essentially similar, right? Like,
Yeah, really the only difference between these models is the percentage of traffic that goes to the new version.
right.
So
Okay.
is it 0 to 100?
Mhm.
Is it 95 to 5?
Or is it 50-50?
Well, and I gotta tell you, that one's a little bit more arbitrary. I've seen A/B testing where it's 95-5, just to be
Mhm.
clear.
Mhm.
The A/B testing, it really has to do more with you testing something, and that's what your comfort level. Like, for example, I mentioned earlier that Google does A/B testing, and I realized that was kind of a mistake because they don't do actually 50-50. They can't because they have like 3 billion users or something. And so they actually have to do like 1% or like 0.5% of total traffic. So they do like 99.5 versus 0.5. And so they're doing A/B testing. They're testing features, but they're not really like testing the entire rollout of an app because they assume the rest of the app works fine. They're just adding like a one new feature, and they're doing A/B testing to see how the thing performs. It's a slightly different model than blue, green, or canary testing, where you're like, I'm rolling out a whole nother application that has like the same feature set, but might have 12 additional features. And so I'm not just testing one feature, I'm testing like a whole set of features. A/B testing can also do that, but typically you do one feature at a time to really capture good metrics.
Yeah.
So,
Got it.
yeah,
Okay. Yeah.
yeah.
This makes. Thank you.
So A/B is the one that's the most ambiguous. Canary is 95-5 or 90-10. Blue green is 0 or 100 to 100, right?
Mhm. Mhm. Okay.
Amazon loves talking about this, by the way. This is on almost all the exams. It's one of their favorite things. Okay, good. Other questions?
I was wondering, is the difference between Canary and AB more about what you're trying to find out? Like, is Canary like, we're gonna deploy this to a small percent and make sure it doesn't break or do something terrible, whereas AB is, we're not sure if people are gonna like this new version better than the old, or if it's gonna work better. We're gonna try both and use that to decide whether we want the new version.
Yeah, that's really it, because both with blue, green, and canary, you're just testing for errors. Is it going to work? Is it working, or is it going to fail horribly? You're not really focusing on whether users love love the feature or part of a beta test kit or whatever. With A/B testing, you're testing like feature testing, right? You're not really concerned. I mean, you could be concerned about errors, right? But you're more concerned about, well, I just want to isolate. We've added this new feature. Are users using this more and reporting more satisfaction because we added, this or a number of features to this version versus this version, right? So I think that's a good distinction, Rachel, is that canary and blue green are more about, am I running into errors or am I doing fine? A/B testing is more about feature testing and less about the errors. And so it's an over and above from what the other two are looking at. Okay. Let's see. This is probably worth pointing out, is that it is cheaper for you to take a single endpoint and host multiple models on the same like endpoint than it is for you to run multiple endpoints and run the models there. The reason is that because these are Docker containers, it will actually stack them on the same virtual machine. So you actually get better density in some cases. It's going to automatically manage memory and all that based on traffic. And especially if you have auto scaling, it will add more instances as needed. So, again, in that whole vein of simplicity, you can use one endpoint to actually host 3 or 4 distinctly different types of models. And when you make the call to the endpoint, just specify which of the variants you're talking to. That's it. So just know that there's a lot of options. Doing this, by the way, where you have to manually orchestrate it is really a headache, honestly. So this really does solve a lot when deploying inferencing. Okay. let's talk about some inferencing types, of which we've kind of touched on these already, not hard concepts. Batch and real time, right? So again, you can do it in two different ways, right? You can use they have a product called transform, batch transform. They have a product called batch transform that get predictions for an entire data set, or you can get it for an entire data point, right? So it's just a persistent endpoint to get one prediction at a time. So you might want to consider, because you might not need to actually have a running instance all the time. You just might want to kick out a batch transform, launch a data set at it, let it run the transformation, and then get back to you, right? I will tell you that if you need real time, right, you want it quicker than, let's say, I would say, somewhere between 5 and 10 minutes. They actually often will go quicker than that, so don't let me throw you off. But typically, you're going to want real-time inferences, real-time predictions. So you're probably going to run an endpoint, but you can just like call a batch if you just need it. I'm just going to throw all these at you. Like if you're doing once a day, where you're like, hey, I just need, I need inferences just for this entire data set because, tomorrow morning we're going to do this. And so I just want to see what you predict, right? It really just depends on what the integrating application needs. Do you need real-time, fast, speedy interaction? Going to do real-time online. Do you like, we're just going to do this once an hour, once a day, once a month, once a week, right? Then we just use batch for that. If it doesn't need to be able to be up for 24/7 and instantly responsive, then just use batch. So yeah, just ask yourself the question, is that, can you just process these in batches, right? Is there a large interval of time between when you actually need these? Sub-second latency, right? That's another good question. If you don't need sub-second latency, this would work. Man, spammers are so active. By the way, you could actually set it up so that, you could just run the job on a scheduled basis. Now, how you schedule that, it's up to you. You could also, just say this, you could use CloudWatch events for that if you wanted to, right? But you just create a batch transform job, via the API or the console. All you really need is the path through the S3 bucket where you've stored the data you want to transform. Obviously, you're going to want to specify the compute resources, like what size are you going to use to process the batch? Where do you want to store the output of the job? That's listed there as well. And the model that you want to use to create the inferences. So when you run a batch job and you specify that, it's going to take care of launching all the compute resources that you need. So it's going to launch them and it's going to delete them after the batch transfer job is done, right? So it's going to manage all the interactions between the data and the model. It's going to use that agent that you see there actually to manage all that. That kind of thing is actually easily distributed because, right, it's just going to break up all the data points across n number of boxes. So, yeah. Again, though, if you need it in real time, that's where you're going to use online or real time, right, to host your endpoints. So you imagine, it's like you're talking to your little Echo and you're going to say, hey, can you play some music to distract crying toddlers? I don't even know what Baby Shark is by Pinkfong. I've seen that like a million times. I feel like I need to look that up now. When you create the endpoint, by the way, oh no, I have 14-year-olds. He's not really a kid anymore. Not with the amount of sass I get. So don't look it up. Yeah. So once you provide the endpoint configuration, by the way, to SageMaker, it's going to launch the instances, deploy the model or models as specified in the configuration details. And then it will give you, right? It'll give you the endpoint, and you've seen this already. So then if you want to consume the model, you just use the endpoint to make inferences, right? So this is going to be your real-time sub-second latency. So SageMaker is going to handle all that for you. You just need to give it the specifications and it's just going to take care of it. I have no comment for what's happening. You know, it's just cracking me up. Okay. All right, so here's some best practices around basically the distinctions between inferencing, which is basically just production predictions, and then training your model, right? So probably key things here is that training's gonna, you know, training's gonna benefit from a speed if it can actually be done in a distributed manner, right? Meaning you can actually distribute it, but not all algorithms support that. So just something to keep in mind, right? Inferencing, like when you actually have a trained model that can actually make predictions, that requires a very relatively small footprint compared to the compute horsepower you're going to need for training. So what this means, for example, is that you could actually run, you know, things on the edge. You could run inferences either on like, you know, CloudWatch style infrastructure, or you could run it on IoT devices, or you could run it, you know, on security cameras as an example, right? That kind of thing works. So inferences are going to run on the edge, you know, like an Echo or whatever. And, you know, your training jobs, though, are going to require a lot more horsepower. So, and training should be relatively infrequent once you get past the initial cycle, because at that point, you're just going to train against new data and probably old data as well. But again, depends on what you're trying to solve. You're just going to train periodically on new data sets, create a new model, which then gets deployed out. But that training is going to be relatively infrequent past the initial run. Now, auto scaling, as I mentioned before, is your ability to say, hey, and by the way, this isn't for notebooks. You don't need auto scaling for notebooks because that's just for, you know, end user consumption, right? Data scientists, developers, etc. You don't really need auto scaling for training because you're just going to specify, although, you know, honestly, that would be cool. You don't need it really for training. Because you're just going to specify whether it's distributed or not. You're going to specify the number of instances that you want it to use. But in production, especially when your access patterns are unpredictable, inferencing could be very useful. This is where this whole concept, sorry, auto scaling could be useful for inferencing. This is where this whole concept of which family do I use makes a lot of sense. Now, I will tell you that the mid-range and below P and G families are going to provide GPUs to you, as we talked about on day one, but they're not going to be as cost effective as you, for example, running a C family and then attaching an Amazon Elastic interface, an Elastic Inference, which is really just a set of GPUs to the actual C family. So just know that generally using Elastic Inference is going to be cheaper than you running one of the big honking kind of like P and G boxes. Okay. Plus you can just strip it off when you're done.
That's specifically for inferencing?
Well, mainly I would tell you, like, for anything, you know, deep learning related, right? That's probably where I would look at neural networks, deep learning, that kind of thing. I would probably focus more on GPUs in that particular case. Otherwise, you may not actually need GPUs. Like, for example, you know, if you're doing like image processing, audio processing, deep learning, or intensive jobs, that probably would make a lot of sense. Other training jobs, if you're doing deep learning jobs, you know, definitely would look at that, right? Notice the difference between training and inferencing. And then, you know, if you're doing inferencing jobs that are not really deep learning jobs that you're inferencing, you probably don't need GPUs for that. But again, I would just test it out. If you start a box and you later want to add Elastic Inferencing to it to see how it performs, you can do that. It just needs to be in a supported framework for your model. I will say that Elastic Inference, you know, when we talk about, you know, your model framework, for example, it has to be supported in like TensorFlow and MXNet. I don't think it supports Chainer. I want to say that PyTorch support was released, but that's speculation. I don't remember that. If you're using Onyx or some other framework, just export it and import it into MXNet. So for training jobs, consider GPU instances if you have like audio, video, like processing, deep learning, just for training purposes. Other jobs, you probably don't need it. For inferencing jobs, you won't need it for image processing and audio processing, but you'll still need it. You could possibly need it or see a huge improvement if you're doing deep learning inferencing in production. Yeah. Hold on just a second. Does that answer that question, by the way? It was very timely. Okay. It says PyTorch coming soon. I think PyTorch is out. Note, by the way, they're like t-shirt sizes for the elastic inferencing, and I want to say it's like 4, 16, and 32 gigs of memory with a commensurate amount of GPUs attached to that. So Chainer is supported as a framework. Chainer isn't necessarily, I believe, supported for elastic inference. Rachel, hope that clarifies that. Yeah, yeah. Okay. What if your data is not properly formatted or cleaned? By the way, this showed up at least as one question on the exam, right? Just know that you can actually, like, in a sense, put in, let's say you got a single inference model endpoint, you could put in an inference pipeline where you basically do some kind of filtering, cleaning, pre-cleaning of the data as it's submitted in, right, into your inference in order to get predictions. My only challenge with this, and please feel free to talk about this, is that we usually just release specifications back to the application team and we say, look, if you want recommendations, this is what you need to submit. And even with batch, I'll say, look, you can't have any gaps in your data. It's like, we'll tell the application team exactly what we want. Now, does that mean that we shouldn't be filtering for the things that we've asked for? Probably not. But, it seems like if we've told them what we wanted from them and they send us things with null values or whatever, then, they're going to get a bad response and they should handle that. Right. But just to say this, maybe you're nicer than me. So you might want to like add like some kind of pre-processing to the data as the data points or data batches as they're submitted to you. You could use the inference pipeline to run some code like, dummy encoding or the standard scalar or hot encoding or, right. So just know that you can actually put data, like in a sense, pre-processing before your production inferences. So this is what the SageMaker inference pipelines are for. Is so you can do some pre-processing against the data as it comes in. So this way, by the way, you could just pass in raw input data and then generate the batch of real-time inference requests, and you can use it with built-in or custom algorithms, right? So yeah, in general, I don't encourage the submission of raw data, but this is a way that you could get around that, right? By the way, to be clear, the pipeline could be a linear sequence, a sequential linear sequence, right, of 2 to 5 containers that process like the request for inferences on data. So it would go through, in a sense, kind of this like cleaning process to take raw data and transform it into something that the model could actually consume. Okay. So this could be, you can combine pre-processing and predictions together. And even, by the way, just to say this, there could be post-processing tasks here. So it doesn't just have to be pre, it could be post as well. Although, yeah, there's probably some considerations there.
So will SageMaker do this automatically, or we do have to actually make that separate container with the pre-processing steps?
I mean, you'd have to generate the container with the pre-processing steps that would have all your code in there, right?
Okay.
Yeah.
I think I just got confused because maybe I misunderstood the notes underneath.
Well, the inference pipelines themselves are completely managed, right? So once you submit it, it's going to do it for you, right? As far as like managing the distribution of containers and aligning them with the model. And as long as you set them in sequential order, it'll do that for you.
Okay,
Yeah, but like obviously the code itself, you're going to have to submit and commit and create. Now, inferencing pipelines, sorry, that I can see where that might have thrown you. You can submit your code into the inferencing pipeline and it'll create the container there, or you can use your own custom container. So maybe that's where I was throwing you off. Is that what you were looking for clarity on, Angela?
that definitely helps. I think I'm reading too much into the sentence here that says, you can reuse the data processing steps during inference without the need to maintain 2 separate copies of the same code. I thought that was implying that you could just submit a bundle, I guess, but it sounds like you make a data processing container, a model inference container, and you submit both to inference pipelines. Is that correct?
Well, what they're saying is that the same pre-processing code that you used in model training, you can then just use that in your inferencing pipeline. So you don't need to maintain 2 separate copies of the same code. It can just be sourced from the same thing.
Okay. Sorry.
Right? Yeah. So that whole like series of code can just be stuck in a pre-processing container, executed. It can be the same pre-processing code. All you need to do is maybe just pull it out of the notebook, right? And so it can be executed as a script. That's it, right?
Okay.
Yeah.
Thank you.
Yeah. Okay. So that was all about inferencing. They will ask you at least one question about inference pipelines in terms of like someone wants to come up with a custom way to accept raw input and pre-process it against the production. How would you accomplish that? The answer is that if you're accepting raw input and you need to process it or transform it in some way ahead of time in production, then you're going to use SageMaker inference pipelines. Okay. That will probably show up at least once on the exam. But at least they're not going to ask you about Clarity and Autopilot and the other 15 SageMaker services we haven't really talked about. But that one they will. Okay. And then we're talking about monitoring. Oh, sorry. Yes. Let me say that again. They're going to ask you a question that says you have an inference deployed on an endpoint and you want to be able to accept raw data, but you want to be able to process it with the endpoint. And so the answer will be, if you want to pre-process the data that you're receiving, because you're receiving raw data and you're running something in production, the answer is to use SageMaker inference pipelines to pre-process the data before it gets to the model inside of the endpoint. Exactly what's being shown here. So that's the thing they're going to emphasize. And they'll give you a bunch of other answers, like write your own Lambda function to sanitize it ahead of time, pipe it here and have it run through an ETL job to get to the endpoint. The answer is just use inferencing pipelines to scrub it before it hits the model.
And that's because that's the simplest answer there.
That's right. Because you could use a Lambda actually, and you could run it through another service. You could actually use an ETL job. Yeah, I don't know about that last one actually. I mean, you could do some of it with ETL. I don't know if you can do all of it. Actually, that's not true because you can run Python on ETL, so you could do everything. So yeah, but you could use an ETL job, right? Using Glue, for example, to do that. But the easiest one is going to be for the SageMaker inference pipeline. Not a separate job, not a separate Lambda function, not a separate API call. Cool. Are we good? Okay. So let's talk about monitoring. Again, high level concepts. Obviously, you want to monitor your models in production. So, models are obviously typically trained and evaluated with historical data, but you're going to be getting new data all the time. Eventually that data is going to accumulate to a certain point because you're going to start seeing decay or concept drift inside of your model's predictions. So this gradual misalignment in the real world needs to be attended to. So, generally having a pipeline to do this kind of automatically is kind of like recommended, because, otherwise if you don't, then you're going to take people and have to go set it up and rerun the processing jobs and all this other stuff. If you already have code for all of that, then just set it up as a pipeline. Now, again, whole class dedicated to that, but that's the general idea. So with that, since monitoring is a huge piece of this whole thing, looking at the three, because there's like 11 sub products underneath CloudWatch, the three main ones that you're probably most interested in are logs, which is where you could emit logs, which by the way, can then be converted into metrics. Then there's alarms, which is the purple one on the far right, where you can actually trigger some kind of alarm response based on the metrics that are either in the logs or just in plain old CloudWatch metrics, because that's what the metric section is called. It's just called CloudWatch or CloudWatch metrics. So just know that logs can be converted into metrics, and then they can be alarmed against. The other thing is that, like I said before, is if CloudWatch events, if it detects a change in your resources, like a change in state, which is, by the way, usually reported to it by AWS config, just so you know, you can trigger auto healing. You can trigger a data job. If someone writes to an S3 bucket, it can trigger that. You can basically do full event-driven responses by using CloudWatch events based on changes in your AWS ecosystem. So remember that in general, alarms is used for notification and response to metrics. Events is responsible for sensing any changes in your ecosystem. So metrics monitors operating systems and other service jobs. Events looks at the service infrastructure itself and configuration itself. There is some overlap, but not a whole lot. And then remember, CloudTrail is a security function. It's not a monitoring metrics function. It's a security function. So its job is to capture all API calls related against your account. And it says and related events. It's just API calls, right? You can write those out to an S3 bucket, right? And you can specify, you can grab source IP address, what call were they making? Do they have permissions? That kind of thing. So if someone is invoking SageMaker a lot, and you want to check the number of invocations, this is a great place to see who was doing it, how many times did they do it over a period of time, etc. So those are the two main services that you use to track SageMaker jobs. So concept drift, right, where there's decay or decline in the predictive quality, right, of an inference endpoint. How often should you retrain your model? The bottom line is that you should retrain it as often as the decay or deviation gets too large for the business to accept, right? Now, you could use a cron job, not necessarily recommended, or you could use a cron job inside of CloudWatch events, which of course, since it's a managed AWS service, that's what they're going to recommend. So you could just literally trigger a training job to rerun and then trigger a deployment and all the other subsequent items. You could do that with CloudWatch events easily based on time, or you could trigger it. Like if an alarm could get triggered that then calls CloudWatch events to re-trigger a job in the event that all of a sudden you see a metric fall beneath a certain threshold. So CloudWatch events would probably, just so you know, trigger what's called a step function, which is an orchestrator for multiple Lambda functions to go out and execute a training job and So just know there's typically considered to be an intermediary step called step functions, which is an orchestrator for Lambda functions. So monitor for concept drift, get notified, or maybe even trigger an automated response. So, and then by the way, you could do it either blue, green, or canary, or AB, or whatever you wanted to, right? And that value could be like, hey, if it drops, 30%, whatever number makes sense to you. Now, There is a model monitor. There's a bunch of like new stuff inside of SageMaker that's come out within the last 6 months. But basically what this does is it basically detects whether there's any errors in like, in your models in production. And it's just going to detect changes in quality of your model, but you're going to predetermine like a threshold, right? So you can use the built-in rules to detect, or you can write your own rules. There's no issue there. And then basically it's going to monitor and emit metrics and give you a pretty dashboard that's going to show up in SageMaker Studio. And then you can actually use that to trigger corrective actions like against alarms based on certain thresholds being crossed, which we've already talked about. So this is like a dashboard, if you will. Has like built-in statistical rules, will detect, large deviations, outliers, that kind of thing. Let's see, other things to think about when it comes to methods of deployment, because this was all cloud-based stuff. Other things to just consider is that one, if you need to push things to the edge, you can, but just know that sometimes because of the size of the frameworks and everything that's included, you might need to optimize the framework and the model, right, to like run in a certain context. So like, for example, in this case, if it was like a security camera, right, instead of sending it all the way up to the cloud for analysis, is there a certain type of, like, for example, image recognition that it could do without having to go all the way back up to the cloud, right? Well, that depends on the model. So IoT Greengrass, by the way, will allow you to do ML inferencing on local devices, right? And these are basically trained and optimized in the cloud and then deployed, right, into these. There's like they're like tiny little Linux boxes, right? But it'll allow you basically to deploy out to them. You can basically create it on SageMaker, then convert it into IoT Greengrass, and then it basically containerizes it and then kicks it out to whatever field device. If there's any deviations or outliers, by the way, they can get kicked back to SageMaker. This does assume connectivity, by the way, for the IoT device, which is not always the case. So the other thing is that Amazon has the SageMaker Neo, which is basically a compiler that allows you to like transform these models into like 1/100th, 1/20th, 1/50th of their size. And it comes with a runtime component as well, right? So it is specific to the underlying hardware that it's using. So this allows you basically to compile something specific for a particular device and basically do inferencing on that device as a result. And the models, by the way, usually are just way smaller, right? Smaller memory footprint, smaller size overall. It's kind of ridiculous. Neo, I think, was in the practice exams. I don't know that it was on the actual exam. But just know, if you need to optimize your model for a much smaller footprint, Neo is probably going to be the thing they're going to recommend, especially if it's like a mobile device or some kind of edge device. They're going to recommend that you use Neo to optimize for that edge case. Okay. Are there any cons against Neo? Sometimes if you've done a lot of customizations on your framework, sometimes Neo won't like be able to do any conversion, at least not run it the same way. So you just need to test it, that's all. Because like it says there, it does convert it to a common format, but sometimes things are lost in the conversion that will break your model's ability to run. So
something I've seen is a recommendation that we put SageMaker Neo and then Greengrass and then deploy to the field device.
Mhm.
What do you think about that?
No, that works great, actually. Yeah, because I mean, you're optimizing, then you're kicking it to IoT Greengrass, which is doing its own optimization. It's already familiar with Neo, and then it's basically just kick it to the device. I don't know that I've seen orders of magnitude of improvement in that translation, but managing the deployment and all that through IoT Greengrass is way easier than you doing it yourself. So there's other benefits to using Greengrass other than just the deployment conversion portion.
Okay.
Yeah. Okay. I mean, right, so I think you can, right? I don't think there's any issue with that at all if you're looking for, to minimize it. But again, breakage can happen. It's like one of those things where I was like, well, why are you running a custom framework again? And they're like, because I want to, right? It's like, okay. So again, it does need to be a supported framework for conversion, but you'd be shocked at the number of people who are just running their own heavily customized, heavily modified, or edge case frameworks that are not MXNet, PyTorch, Chainer, et cetera, because they just don't like the other ones. So yeah. So I would say, yeah, why not? Right. Although, funny thing is that if you have a tremendous amount of horsepower, and it's the difference between 28K and like 15K, they may not make that much of a difference. So. Okay. So we talked about rolling your own EC2s versus using basically a SageMaker endpoint, which could have auto scaling behind it, different variants. We talked about all kinds of stuff around, when do we use elastic inference? When do we not, right? Learning, deep learning, obviously on the inferencing side. If it's deep learning and audio and video on the training side, GPUs might make a lot more sense. But, then again, it just depends on what you're doing. What services you need to talk to in order to find metrics and API calls inside of AWS. We talked about various kind of like optimizations that you can do, especially for edge devices. Yeah, and then we talked about the difference between batch and versus real-time processing. They're definitely going to ask you questions on that. Okay. Any questions before we move forward? Okay. So let's talk about this last little piece. So before I roll into post-assessment, let me just go ahead and wrap up the course, because I'm going to end you with the post-assessment that way, but I'm going to hang out with you, so I'm not leaving, right? But I'm going to hang out with you. I'm going to give you the post-assessment so that those of you who are done, we're done, right? We've already done the practice exam portion for today. We've talked about deployments. You've worked on the final section of your lab. Just remember, by the way, the skill builder thing that most of those links refer to inside your certification study guide. There are ridiculous numbers of trainings and information out there if you need it, right? Again, don't try to consume everything, just consume the things that are most relevant. We already talked about certification, so I'm not going to touch that, right? And then just ignore this next slide for a second. Now, the other thing is that we're about to do the assessment. And ignore this because that's not even valid. I'm actually going to post the WebAge evaluation in there in the chat. But technically, this would, after the assessment, this is going to be the end of class. Now, I'm going to hang out just in case to answer questions about labs after you've done the post-assessment. But just be aware that that's it. That's the end of it. So to that end, let me just make sure that my recommendations here are super clear, right? Is that you use the certification study guide, you pick and choose the pieces that you feel like you're challenged on, and then you start running through the practice exams, and obviously get hands-on if you need to, but you start running through the practice exams, do one of the review mode set exams until you can build yourself up to 90% or more, and then do the next one until you can get up to 90% or more. Once you've done those 2 exams, you're ready to sign up for the exam. And there's a you know, I would say a relatively high probability if you've done the expertise building and you've done the practice exams that you're gonna pass. That's not a guarantee, but there's a high probability at that point in time. So, and then at that point in time, I would then maybe go back and take a look at some of the other resources that are in there, including the ramp up guide. And maybe just go ahead and round that out. There's tons of other SageMaker services out there that, you know, we didn't really touch on. Clarity being one, AWS Forecast, Autopilot, there's tons. They're announced all the time. So I would probably go back and take a little bit more look at that ecosystem, because there might be managed services there that you would actually use instead of actually running your own models, kind of like how we use Poly and, well, not Poly, but Rekognition, Lex and other things, right? And that's it. Questions before we roll on to the final assessment? Okay. All right, here we go. Let's see, there's the link. I'm gonna post the link in the chat. Page should look like this. Please put Forrester in there as always.
Hey,
And
Mike.
then, yes,
Yeah, sorry. You may have asked it or answered this throughout the course at some point in time, so forgive me, but is there instances where it'll on the exam where there's like code given and it'll be like, what's wrong with this code? Or, like very code related, like specifics?
nope,
Cool.
yep, no. I can say that with comfort. All right, so this one is supposed to last for 45 minutes. So technically, let's say it's 3:30 now. We're gonna check back in at 4:15, okay? The minute you're done, by the way, if you're done with your lab, you're done. If you're not done with your lab, well, then you probably wanna go take a look at it and spend I think unfortunately, like it's probably like the last 20 minutes or so when we at 4:15, but yeah, so you want to like run through that, but hopefully if it's finished all of its major training jobs and you probably just have some confirmation left. Okay. I'm not going anywhere. I'll be here till at least 4:30. So we'll check in at that time at 4:15. We'll check in. Okay. Meanwhile, do this, test your knowledge. And I'm going to post the evaluation link so you can evaluate the class, talk about additions. Please note that our CEO reads them and they will eventually get to AWS. And thank you for all your corrections. I've captured, I think, most of them. Everything from like little typos to just outright errors, right? So thank you for that. So it's been a pleasure. 45 minutes, go to it. And hopefully I'll see you at the next class, or you can join us for exam cram next week if you want to dive into that. But otherwise, thank you for hanging out with me.